Homework U4, question 5. This question starts by asking us to derive the formula for the sum of a geometric sequence. Start by writing out this geometric sequence in full. S equals A plus AR squared plus ... our final term, AR to the n minus 1. Next step is you want to multiply both sides of this equation by r to get SR is equal to AR plus AR squared plus AR cubed plus all the way to our final term, which is now AR to the power n. Now all but two of these terms now match up, one in the top line and one in the second line. The only ones that don't are our A in the first line and our AR to the power of n in the second line. This is two simultaneous equations, 1 and 2, and I want to do one take away the other. Now there are two different versions of the sum of a geometric progression, so it's important to know which one is going to get you which, and I want to do the one which starts with a take away r to the power n. So the one that I want to do is equation 1 take away equation 2. On my left hand side this gives me s minus sr, and on my right hand side all of these middle terms are going to cancel, so the only one that I'm left with is a, and this one doesn't have anything to cancel out, so I'm going to end up taking that one away, AR to the power n. I want to factorise both sides of this equation. S lots of 1 minus r is equal to a lots of 1 minus r to the power n. And finally, dividing through by that bracket gives me a lots of 1 minus r to the n all over 1 minus r, as required. In part B, I've now been given a third and fifth term of a geometric sequence. The third term can be written as AR squared, and that's equal to 5.4. And the fifth term can be written as AR to the power 4, which is 1.944. Again, I've got simultaneous equations here, and this time I want to divide the second one by the first one. So I get AR to the 4 over AR squared is equal to 1.944 over 5.4. The a terms cancel from this left hand side, and I can also cancel out an r squared from top and bottom to be left with r squared is equal to 0.36. Square rooting gives me r equals plus or minus 0.6, but as all terms in the sequence are positive, that means that r has to be the positive square root. In part C, I'm then asked to find the first term. Now that I know what r is, I can plug that into either of my two equations. A times r squared, which we had earlier was 0.36, is equal to 5.4. This gives me a value of a of 15. And any time I solve simultaneous equation question, I should check that the two solutions that I get work in my second equation. And if you check on a calculator, 15 times 0.6 to the power 4 is 1.944 as required. In part D, we're then asked to find the sum to infinity. Our sum to infinity formula is given as a over 1 minus r. Using my values that I found earlier, a is 15, r is 0.6, and so again on a calculator this gives me 37.5 as a final answer.